We're talking today about trigonometric identities. When you have an identity in a mathematical situation involving x or some sort of variable, it means it's a relationship that's true no matter what the value is. So for a trigonometric identity, no matter what the angle is, it's always going to be true. So if we go back to a few lessons ago, remember this unit circle that we had with x and we had y, and we found out that x is equal to cos theta and y is equal to sine theta. That's just basically doing the fact that if the angle inside the triangle is theta, adjacent over hypotenuse is x, which is cos, and opposite over hypotenuse is y, which is sine theta. Now if we use Pythagoras' theorem, x squared plus y squared equals 1. But if x is cos theta and y is sine theta, then we get this fairly important identity that you need to kind of remember. Sine squared, it is on your reference sheet, but it's good to be having this one as kind of a go-to identity in trigonometry. Sine squared theta plus cos squared theta is equal to 1, and that's true for any angle. No matter what the angle is, it's always true. And it's called a trigonometric identity. It's always true. Now, if we look at it, if I rewrite this identity, so we get sine squared theta plus cos squared theta is equal to 1, I'm going to be able to find a couple of things. But before I come back to this, I need to sort of look at a couple of relationships. Firstly, we remember this. Tan theta is equal to sine theta over cos theta. Why is that? Because in the triangle at the start, tan theta is equal to opposite over adjacent, y over x. And again, if y is sine theta is x is cos theta, then tan theta is sine over cos. Now this is also an identity, so we want to be familiar with this one. And a couple of other ratios. We've got sec theta is equal to 1 over cos theta. That's kind of the definition. So in a right angled triangle, sec would be hypotenuse over the adjacent. Cosec is 1 over sine. And cot theta, cotangent, is equal to 1 over tan theta, which another way to think about it is cos over sine theta. It's the reciprocal of tan. If tan is sine over cos, then cos is, if tan is sine over cos, then cot theta is equal to cos theta over sine theta. So coming back from that, if we have a look at this, sine theta plus cos theta equals 1. Now let's imagine that I divide everything by cos squared theta. Divide by cos squared theta. So every term, both sides, we're going to divide by cos squared theta. Now what's going to happen? We're going to hit sine squared theta over cos squared theta plus, well, cos squared theta divided by cos squared theta is just 1, and that's equal to 1 over cos squared theta. Now we just saw that sine on cos is tan, so this becomes tan squared theta plus 1 is equal to 1 over cos is sec theta, so this becomes sec squared theta. And there we have another version or different identity between tan and sec. That's another one that we might be able to use. But the good thing is, if you remember the first one, we just think, okay, I just divide by cos squared and I'll be able to get to that one. Now, there is another variation using another set. So I'm going to rewrite the original again. Sine squared theta plus cos squared theta is equal to 1. Instead of dividing everything by cos squared theta, what if I divide everything by sine squared theta? Divide by sine squared theta, divide by sine squared theta on both sides. And by both sides means you have to divide all the terms. Sine squared theta divided by sine squared theta is 1 plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Now, again, if I think about it, cos over sine is cot. So this becomes cot squared theta is equal to 1 over sine squared theta, or 1 on sine is cosec theta, so this becomes cosec squared theta. And again, here is another version of an identity which is very closely related to our sine squared plus cos squared is equal to 1. So, going to have a look at some examples, but go to the next video for that.